Hi, I'm astronaut Mario Runco, and I've had the rare privilege few have had of seeing our home planet from space. The Earth is certainly a beautiful place, and astronauts over the years have returned to Earth with breathtaking images of our home planet. Now, for the first time, the International Space Station provides the ability to take more than simple photographs of the Earth. With the window installed in the U.S. laboratory module Destiny, there is the capability of acquiring multispectral and hyperspectral data and high-resolution imagery. This optical quality science window was meticulously calibrated prior to its installation in the Destiny module. It has greater than 95% transmission across most of the visible spectrum and better than 90% in the near-infrared bands. The window will support sensors and instruments with apertures of up to 350 millimeters in diameter, making it the highest quality window that has ever flown on any manned spacecraft. The window port is 20 inches in diameter and is actually composed of 4 panes of glass. An exterior debris pane that protects the entire assembly from impacts with space debris while the external shutter is open, 2 pressure panes that maintain cabin pressure, and on its interior side, a removable scratch pane. The scratch pane protects the interior pressure pane from internal contamination and debris and has a built-in heater to prevent condensation from forming on the window. While the scratch pane allows occasional access to the window for crew Earth observation photography, it is not of the same high optical quality as the other 3 panes, and therefore must be removed and stowed for science operations. The whole assembly is protected from the space environment by an external shutter. Supporting the science instruments that would be placed in Destiny's window is the Window Observational Research Facility, or WRF for short. The WRF is the rack that is installed over the window and not only provides the necessary access to the window itself, but also the power, data, and cooling connections required for science instruments to operate. I'm here in the Space Station Processing Facility where the WRF rack is being prepared for launch. The WRF's payload volume has approximately 27 cubic feet of available space, about 3 feet on a side to accommodate instruments. The entire surface is coated with a flat black, non-reflective finish to reduce stray light within the payload volume. The payload shelf, located within the lower portion of the payload volume, provides a stable platform on which to mount instruments. The mounting surface is 3 feet by 2 feet and is configured with 165 threaded inserts on a 2-inch grid that require 1032 screws. The platform provides a line-of-sight stability of approximately 19 microradians depending upon the mass of the instrument. For more demanding instruments, a detailed analysis should be performed to determine whether an individual instrument will require additional stabilization. On the sides of the payload volume is an array of standard ISS seat tracks, 5 rows on each side wall in all, on which can be mounted any ancillary equipment needed to support payloads. Only items that do not require stability should be attached to the seat tracks. There is also seat track on each side of the front face of the WRF for the same purpose. Opposite the payload shelf is one of the connector panels that provide the power, data, video, and cooling lines for installed instruments. There are 3 available sets of payload connectors on this panel. Each set has a power outlet providing 28-volt DC power with selectable current that can be set at 5, 10, 15, or 20 amps, and an instrument data port providing Ethernet, RS-422, RS-232, and RS-170 or video connectivity to the payload LAN and the WRF laptop computer. The WRF laptop computer will reside outside the payload volume on the front of the rack and is connected via the laptop connectors on the front connector panel. The front connector panel contains 2 more sets of payload connectors with the same power and data availability as on the internal payload connector panel. This panel also provides the connections for the WRF laptop computer, including a 28-volt DC power outlet with selectable current, an Ethernet connection, an RS-232 data port for rack commanding and health and status, and a 2-way RS-170 NTSC video port. An instrument package may also be controlled, operated, and monitored locally by the crew via the use of the pass-through connectors, a set of which is provided on both the front and payload volume connector panels. These permit direct connectivity from an interior instrument to support equipment outside the payload volume when the hatch is installed. There is an additional connection that can carry 120-volt DC power from one of the many utility outlet panels in the Destiny module to the internal payload connector panel. These are intended mainly for the crew to use for portable lighting and ventilation when they are installing and removing equipment. The environment within the wharf payload volume is regulated by an internal environmental control system, the heart of which is an air-water heat exchanger located beneath the payload shelf in the bottom section of the rack. The avionics air assembly, or AAA, is the fan that provides the air circulation for the system. The AAA also provides airflow across the window through a long, narrow vent known as the air knife to prevent condensation from forming on the window when the scratch pane is removed. The air knife is located at the rear of the rack, just below the window.